Hello students, let us solve the following exercise. They say in the Bohr model of the hydrogen atom, an electron with mass of 9.1 times 10 to the negative 31 kilograms orbits a proton at a distance of 5.3 times 10 to the negative 11 meters. The proton pulls on the electron with an electric force of 8.2 times 10 to the negative 8 newtons. So, how many revolutions per second does the electron make? So, what information we have here in this problem? We know that we have an electron moving in an orbit, which is a pretty circular orbit, right? And there is a force that is that the force that the proton hurts on the electron, that we know the magnitude, right? That will be the electric force, will be the force of Coulomb, which is 8.2 times 10 to the negative 8 newtons. So what happens here? If we have an electron moving in circular motion, is because there is a net force, right? And associated with this net force, there is a centripetal acceleration. This centripetal acceleration, as you know, will be the net force divided by the mass. In this case, this mass will be the mass of the electron. So we can calculate the centripetal acceleration of this electron, right? Using the value of the electric force, that is the only force acting here, so it's the net force, and using the mass of the electron. Now, why would we need to calculate this centripetal acceleration? Because we are looking for n, that is the number of revolutions, right? But this number of revolutions is related to omega, which is the angular velocity. And this omega, we know there is equal to 2 pi times the number of revolutions. Now, how is omega related with the centripetal acceleration? Well, we know that the centripetal acceleration is the square of the tangential velocity divided by the radius of the orbit. But at the same time, we know that the tangential velocity is the product of the angular velocity times the radius. So we have angular velocity times the radius square here divided by r. So we will have that this centripetal acceleration would be w squared r squared over r. So canceling r out, it would be omega squared times r. So this would be my centripetal acceleration. So that means, that if I calculate the centripetal acceleration, I will be able to calculate then omega. And once I calculate omega, the angular velocity, I will be able to calculate easily the number of revolutions. So let us then calculate the centripetal acceleration here. So we have 8.2 times 10 to the negative 8 newtons divided by the mass of the electron, which is 9.1 times 10 to the negative 31 kilograms, right? Now, we're going to divide and work with the scientific notation, and we're going to get, right, that this would be approximately 9.0 times 10 to the 22 meters per second square. So remember, when you have here 10 to the negative 8 over 10 to the negative 31, you bring the 10 to the negative 31 up as 10 to the 31, right? So you will be later adding exponent, which is really a subtraction here, right? And then this would be 10 to the 23rd, right? 10 to the 23rd. And of course, your quotient was 8.2 divided by 9.1 would be like a 0.9 something. So 0.9 times 10 to the 23rd would be the 9 times 10 to the 22nd, right? So this is why we get here 9.0 times 10 to the 22nd meters per second square. So once you know the centripetal acceleration, you say, oh, I know that this is omega squared r, right? So as I know that this is omega squared r, this is my centripetal acceleration, I will solve for omega. So omega would be the square root of the centripetal acceleration divided by the radius. Of course, we know that omega, as we mentioned before, will be 2 times pi times the number of revolutions. So we say 2 pi n is equal to the square root of the centripetal acceleration divided by the radius. We divide by 2 pi, so we get that n is equal to the square root of the centripetal acceleration divided by r divided by 2 pi. Right? So I can now do my calculations. So I have the centripetal acceleration, which is 9.0 times 10 to the 22nd meters per second square, divided by, I have the radius, which is 5.3 times 10 to the negative 11, right, meters, and all divided by 2 pi, right? So when you just solve these or perform these operations, you will get that the number of revolutions per second, right, that you're going to get is approximately 6.6 times 10 to the 15 revolutions per second. So this is, in this case, the value of n. So this is the number of revolutions per second that you get in this case. So important here to understand that if the electron is moving in a circular orbit, right, is because there is a net force acting there, and there is an acceleration pointing toward the center, and that acceleration is the centripetal acceleration, which is the quotient of that net force by the mass of the particle. And like that, we can just then go ahead and calculate the angular velocity and the number of revolutions. So I hope this solution was interesting for you. So please subscribe to my channel, and I will see you later with more exercises.